Today we are going to talk about how to graph a couple of specific root functions. So we've been talking about square roots and higher roots and different properties of them and simplifying things. Today we're going to look at how to graph them. When we see a new function, one way to analyze what it's going to do and we don't know what it's going to look like is to use charts. And that's what we're going to do for our graphs today. This is not yet your first example, but just kind of looking at how we're going to work through our examples. We're going to make a chart. So this is a graph of what we call our parent function, or just kind of the plain function of this type, the square root of x. So what we're going to do is make a chart. What kind of numbers am I not allowed to pick for x? Negative numbers. If I try to plug a negative number to this, I'm going to have the square root of a negative number, and that's imaginary, so it's not going to work. We're not going to be able to see it. So I can start at 0 and then pick positive numbers from there. I'm going to choose to pick numbers that are going to work out nicely to kind of make my life a little bit easier. So I'm going to choose 1, 4, and 9 because those will work out nicely when I plug them in. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And square root of 9 is 3. So we would plot these points. We have a point at 0, 0, 1, 1, 4, 2, 5, 6, 7, 8, 9, 3, and we get those points, and we would connect our dots. Okay. This function has an endpoint. It does not go on forever in both directions. It stops at that 0, 0 point. That's the end of it. It doesn't go anywhere past there. It does go on forever in the other direction, because I can plug any positive number in to this function. So it will keep on going over sideways to the right, but it stops at that 0, 0 point.
Because it can't go into negatives.
Because it can't go into negatives, correct. If we turn this on its side, like if you turn your head so that it's kind of facing towards the right, what does it kind of look like? Half of a parabola, right? So earlier this year we talked about parabola functions as being the graph of x squared. So if this is the square root, it kind of makes sense that their graphs would have some sort of a relationship with each other. So this kind of looks like a parabola turned on its side, but we don't get the whole parabola. Why? What would be wrong if we got the whole parabola here? What's the problem with that graph? It's not a function, right? It's not a function. If we start drawing vertical lines, we end up hitting more than 1 point, so that wouldn't be a function for us. So we're only going to get half of the parabola so that we have a function. So to graph our root graphs, what we're going to do is take care of any shifting that's going to occur. We talked about function shifting earlier this year, and one of the nice things about function behaviors, all of them behave the same way in terms of shifting. Whatever is with the x underneath the root is going to be a sideways shift, and it's going to go backwards. So this one would go over to the right, h, if it's minus h. Okay, so we talked about how with the x is going to go side to side, like the x-axis is our side to side, but it's actually going to go in the opposite direction of what is indicated by the sign. And then whatever's on the outside is going to be our up or down shift, and it does what it looks like it's supposed to do. So a plus k is going to move us up k. That'll create our endpoint, and then from there, we're going to use our xy chart to plot some more points. So for this one, the first thing we want to do is take care of the shifting that occurs with the -2 and the +1. So with the x is going to go side to side and backwards. So this is going to go over to a +2. The +1 is going to move our graph up 1. So we're going to go over to up 1, and that is going to create the endpoint. So for the plane function that we looked up before, endpoint was at 0, 0. For this particular version of the equation, the endpoint is going to be that point right there at 2, 1. To find some more points, we're going to make an xy chart. When you create your XY chart, you're going to be plugging stuff into the equation only using the parts we haven't used yet. So I haven't done anything with the -3 or the square root of x. I already took care of the 2 and I took care of the 1, so I don't need those anymore. You are always going to choose the same values for x. 0, 1, 4, and 9. The reason we pick those numbers is because they have nice square roots, so it's going to turn out nicely to be able to plot these. So if I plug in 0, square root of 0 is 0, times -3 is still 0. If I plug in 1, square root of 1 is 1, times -3 is -3. Square root of 4 is 2, times -3 is -6. Square root of 9 is 3, times -3 is -9.
Can you go to the chart again?
Yep. So you will always choose 0, 1, 4, and 9 because those have nice square roots. And then to find the y value, you're going to plug those into our abbreviated equations. Not the original one, but we don't need the 2 and the 1 because we already took care of those. So like for a 4, I plug in a 4 for x, square root of 4 is 2, times the -3 gives -6.
Why doesn't the -2 go the other way?
Side shifts always go in the opposite direction indicated for all function behavior. Now when we plot these points, you are not going to plot them from the original origin. Okay, so 0, 0 is not the original origin. These are going to be plotted from the shift point, pretending like that's the origin. So we're going to pretend like that point that's already marked is our origin and plot from there. So 0, 0 is that point. 1, -3 is going to go over 1 from that point and down 3 from that point. Not from the original origin, but from our starting point. And then from our starting point, over 4 and down 6. I can't fit the other one on, and that's okay. As long as you get at least 3 points on your graph, that's okay. If you can get all 4, that's better. It doesn't really fit, so just 3 will be okay. We're going to plot on out this way. That's an endpoint, so we don't want an arrow over on the left-hand endpoint, but we do want an arrow over pointing out to the right because it will go on forever in that other direction.
How do you plot the -2 and the 1? Or what points are those?
That gives us our endpoint. The -2, 1 gives us our endpoint. That we go 2 to the right and up 1, and that creates our endpoint. From the origin. Go 2 to the right and up 1 creates the endpoint of the graph.
So you go opposite.
Opposite for the x. Opposite for the sideways.
Then what are the other 2?
They come from the chart. The other points come from plotting the points in the chart. This question also asks us to consider the domain and range. We don't have to look at the equation to consider the domain because we have a picture. So we can look at our picture to consider our domain and range. Domain tells us about possible x values. So what we want to do is look at on the graph, where does it begin according to x, and in which direction is it going? So our endpoint is that x is 2, and then it goes bigger than 2. So our domain is going to be that x is greater than or equal to 2. Starts at 2, and then it goes out to the right for bigger than 2. Domain is possible x values that would work. Our range is possible y values that we would get out of the equation. Again, this is going to be limited. Range is y. So we want to say, where does y start and in what direction does it go? So that endpoint is at a height of 1, and it goes downward from there. So our range is going to be that y is less than or equal to 1. So that endpoint will give you the values for your domain and range. X begins at 2 and gets bigger. Y begins at 1 and gets smaller. Alright, let's get some more examples of this type. First thing we do is take care of shifting. Anything that is with the X is a sideways shift in the opposite direction. So it's going to go to the left 4. Anything that's out of the root is an up or down shift doing what it says. So down 1. So we're going to go left 4 and down 1, and that's going to create our endpoint. Then we're going to want to make a chart. But when we make our chart, we're not going to use the whole function. We're only going to use the parts of the function that we haven't used yet. So we're going to use 1/3 square root of x. We've already used the 4 and the 1, so we don't need to use them again. Then I plug in 0, square root of 0, 0 times the third is still 0. That point's not really vital in doing because it's always just going to be the end point, and we've already plotted that, so it's not super important that you do that one. It's always just going to give us 0, 0. And I plug in 1, square root of 1 is 1 times the third is 1/3. Again, 4, the square root of 4 is 2 times the third is 2/3. Plug in 9, the square root of 9 is 3 times the third is 3/3 or 1. Now we're going to plot those points from the end point, not from the origin. So from our end point, I'm going to go over 1 and up 1/3. Then from the end point, go over 4 and up 2/3. And over 9 and up 1 from the end point. We connect those points. An arrow pointing out to the right because it will go on forever that way. I could keep on plugging in bigger and bigger numbers of x, but I can't go past that endpoint, so no arrow there. This graph looks different than the last one in 2 ways. One way it looks different from the last one is the last one was kind of a bottom half and this one's a top half. Okay? That's based on our multiplier either being positive or negative. So in the last one we had a -3 in front of it. That made our graph be kind of the bottom half of the parabola. This one has a positive number in front of it, so we're going to get a top half of the parabola. The height of the graph is very different also. Our last one was really kind of tall and stretched out that way. This one is very short. It was hardly growing in height at all as we moved across. That comes from how big the multiplier is. So in the first example, we had a multiplier of 3. That made our graph get pretty tall. This one only has a 1/3, and that small value is going to keep our height small. Okay? So you can kind of use that A value to have a guess at what your graph is going to look like, and it'll help you know that. That if your graph is supposed to be a bottom half because you have an A value that's negative, but yours is a top half, you know something went wrong somewhere. Okay. We now need to think about domain and range on this. Domain and range are possible x and y values. Domain is x, range is y. To get these, we look at our endpoint. So according to the x-axis, where does our graph begin? At -4. And does it go right or left? Right. So x is greater than or equal to -4. It starts at the x's -4 value and goes right from there, or bigger than from there.
For the domain, do we always write the opposite of x?
Yes. Yep. For range, Range talks about y's. Where does the graph begin for y values? -1. And does it get bigger or smaller? Bigger. So y is greater than or equal to -1. Okay. So we look at where that endpoint is according to x and y. Domain is x and range is y.
Why is it greater than the y?
Because it's going up from -1.
Oh.
So it's starting at -1 and going up from there. The last one started and went down from there. Right, so first thing we need to do on this one is take care of our shifting. -3 is going to go to the right 3. +2 is going to go up 2. Then we're going to make a chart for our simplified equation of just y equals negative square root of x. We don't need the stuff that already created our endpoint. Now, basing off of what's in front of this, is it going to be a top or a bottom graph? A bottom because we have a negative there. And what number is in front of it? Is it like a 1? It's like a -1. 1 is kind of considered to be like a medium or normal height. So our first one, we had like a really tall one for a 3. The last one was really short for a 3rd. This is just going to kind of be like a medium height graph. So I'm going to use 1, 4, and 9 in my chart. When I plug in 1, square root of 1 is 1, -1 is -1. Plug in a 4, I get 2, and -2 is -2. Plug in a 9, I get 3, and -3 is -3. Then I want to plot these from the endpoint, not from the origin. So from the endpoint, go over 1 and down 1. From the endpoint, go over 4 and down 2. And that falls off the end of the graph, but I'm going to do it anyway. You want to have at least 3 points on your graph. 2 is not good enough to be able to see the curve happening. They start to look way too straight, or they curve wrong unless you have at least 3 points. If you can't get the 4th one on there, that's fine. But make sure you get at least 3 points on your graph. And then connect our dots. Connect our dots and draw the arrow on the one end. Then domain and range. Where does the graph begin for x? 3. And does it get bigger or smaller? Bigger. So x is greater than or equal to 3. Range is y. Where does the graph begin for y? 2. And does it get bigger or smaller? Smaller. We're going to have a lower half graph, so we're going to go down from 2.
Is number 9 equal to?
We will always have the equal to bar for these. Because the endpoint actually exists. It's not an open circle. That point is actually there. So we want the equal to bar. Questions? Cube roots. A cube root function goes on forever in both directions, so it gets arrows on both ends. That's kind of this S thing that happens in the middle of it. For cube roots, this would be our plane y equals the cube root of x graph. For my chart, I would want to pick numbers that I can take nice cube roots of, which would be -8, -1, 0, 1, and 8. The cube root of -8 asks what number times itself 3 times gives me -8. And that would be -2. -1 times itself 3 times, it can be -1. 0 gives 0. 1 gives 1. and 8 gives 2. So we can plot out these points. And we get kind of this little S that swoops through the middle here. Our last graph looks like half of a parabola because x squared makes a parabola. We haven't studied the graph of x cubed and what that looks like, but if you would graph that out, it looks like this. So still, they kind of look like each other turned on the sides. Okay? We talked about yesterday how inverses are reflections over that line of y equals x. So since these are inverse functions, if I would draw in that line of y equals x, then they should be reflections across that line.
What are these S lines called?
They don't have a name. Nope. For a squared function, we call it a parabola. That has a name. This one doesn't have a name. I call it a swoopy S thing in the middle. But they don't have a good formal math name. We're going to graph them the same way that we graphed our square roots. So we're still going to take care of shifting in exactly the same way. All functions behave the same way for shifting. So that is nice and consistent through all of algebra. For our chart, we're going to use numbers we can take nice cube roots of, but we're still going to make a chart the same way we did for our square root graphs. So for this one, we want to take care of our shifting first. The plus 2 is going to move us 2 to the left, and the minus 1 will move us down 1. So I'm going to go 2 to the left and down 1. Now this graph didn't have an endpoint though, so that's not going to create an endpoint for us. It's going to create the center of our graph, right where that swoop happened. Okay, for a square root, that point we plot gives us our endpoint, but a cube root doesn't have an endpoint. It goes on forever both ways. This gives us the exact center of our graph, or right in the middle of that swoop. Then we're going to create our chart using, again, only the parts of the equation that we haven't done something with yet. So I need the 3 and cubed root of x. The x's you will want to choose for your chart are going to be -8, -1, 1, and 8. Because those are numbers that we can take nice cubed roots of. The cubed root of -8 is -2, multiplied by the 3 in front gives us -6. Cubed root of -1 is -1 times 3 gives us -3. Cubed root of 1 is 1 times 3 gives 3. Cubed root of 8 is 2 times 3 gives 6. Your chart will always have a nice symmetry that happens here. You will get the same values, but negatives for one and positives for the other. Then we're going to plot those from this point again, just like for our square root, not from the original origin, but from the point we've already plotted. I don't have room to go back 8, so I'm going to skip that one, but I'm going to go back 1 and down 3. I'm going to go forward 1 and up 3, and forward 8 and up 6. So our graph swoops through those points and then continues on out the other way with a symmetry of the first half. Once again, the number in the front can tell us about the size and the shape of the graph. And that if we have a positive, it's going to end heading upward. If we have a negative, it's going to end heading downward on the right-hand side. And more so, it can tell us about the height. So having a big multiplier of 3 here made this graph really stretch out tall in the middle of that swoop.
Do not graph -8 news.
Yeah, I didn't have room to graph the -8, -6.
Okay.
For these, you really want to have 4 points plotted. So I said for our square root, you want to make sure you have at least 3 points plotted. For these, you want to make sure that you have all 3 of the center points right around the swoop, and then 1 of the points off to one of the sides so that you can see how tall it's getting there. Domain and range. This graph does not have an end point. So when we think about x's, the arrows are pointing all the way to the right and all the way to the left, which means anything works. And the way we say anything works in domain and range language is all real numbers.
Is that always for domain?
And just as those arrows are pointing all the way to the right and all the way to the left, they're also pointing all the way up and all the way down. So our range will be all real numbers. For cubed roots, domain and range will both always be all real numbers.
Why do you even have domain and range on the bottom?
Because I want you to know that for a cube root graph, domain and range are all real numbers. In your homework, it will ask you as well. So don't skip over it because you think it's silly to write all real numbers. Write all real numbers and get the easy point.
They're always.
For cube roots, domain and range will always be all real numbers. Alright, so first thing we do here is take care of the shifting. -3 goes to the right 3, +2 goes up 2. So right 3 up 2 creates the center of this graph. Then we want to create our chart for the stuff we haven't used yet. -1/2 cube root of x. The x's we use are -8, -1, 1, and 8. Because I don't like dealing with negatives more than I have to, I usually start by plugging in the positive values on my chart. So if I start at the bottom and plug in 8, the cubed root of 8 is 2 times the -1/2 gives -1. And if I plug in a 1, the cubed root of 1 is 1 times -1/2 gives -1/2. Then your chart will be symmetrical. So then I'm going to get +1 and a +1/2 for the other values. So you don't actually have to plug in all 4 because there's a nice symmetry to it. So then from that center point, I'm going to go back 8 and up 1. Back 1 and up 1/2. Forward 1 and down 1/2. And I don't have room to do that other one, but that's okay. As long as you at least get one of those side points plotted in, then that's okay. You want 4 points total in this graph. At least. If you can get them all, that's great. So this one was a small multiplier of 1/2, kept the height small, and with the negative, it means that it's ending heading in the downward direction as we go out to the right. Domain and range are both always all reals for cube root graphs. First thing we take care of is our shifting. -1 is going to go to the right 1, +1 goes up 1. Then I'm going to make my chart for the stuff I haven't used yet, which is just a cubed root of x. -8, -1, 1, and 8 are our x values for cube roots. Again, cubed root of 8 is 2, cubed root of 1 is 1, and you'll have a nice symmetry to just get the negatives for the other ones. Then from that center point, I'm going to go back 8. It doesn't quite fit, but I'm just going to go ahead and do it anyway because I want to have at least one of those side points. So I'm going to go back 8 and down 2. Back 1 and down 1. The right one and up 1. And I don't have room to go to the other one. You can if you want. You don't have to. As long as you have at least one of those far points in, that's good enough. And domain and range for a cube root graph are both always all roots. Your homework, I don't think always separates and says these ones are square roots, these ones are cube roots, so pay attention to what it is. And also, sometimes they don't always look like they have a root in them. For example, if I had a problem that asked you to graph y is equal to 5x to the 1/3, what does that really mean?
5 cubed roots of x.
5 cubed roots of x. Remember, a fraction exponent is really a root, so that the top is the power and the bottom is a root. So that denominator of 3 really means we're talking about a cube root there. So look out for those.
Is there any graph